In this example, we're trying to work out how much I is changing. So we're trying to find a change in I when there's a change in V and a change in R. And here's the way in which I, V and R are related. So we're trying to find how much I changes, so delta I, change in I, and from the above formulas, there should be di dv times how much V is changing, plus the partial I, partial R, times how much R is changing. In fact, this is the way in which I changes as V changes, times the amount of change in V, and then similar for R. So we've got things for some of these. So the change in V we know is 1 volt. The change in R we know is half an ohm. So we need partial I, partial V, and partial I, partial R. It's just a matter of using this to do it. So partial I, partial V is just 1 over R, because V is the variable and R is the constant in this case. And the other one, partial I, partial R. Okay, so how are we going to do that? Well, this formula is the same as I equals VR to the minus 1. So if we differentiate that, partial I, partial R, we get negative VR to the minus 2. So it's the same as negative V over R squared. So it's just a bit of an aside over here. So the increment in I is equal to di dv, which is 1 over R, times the change in V, plus di dr, which is negative in this case, so minus V over R squared, times increment in R. And then we can just stick things in, so 1 over R is 50, times the change in V, which is an increase of 1, so it's just 1, minus V, we're told is 250, over R squared, times the increment of R, which is 0.5. If you chuck it into your calculator, that can be negative 0.03. So a decrease, okay, negative is a decrease of 0.03, whatever I is measured in, and this question doesn't tell you, but if you needed to know, you would. That's current, so it'll be in amps. So there we go, we now have a increment in the current, worked out from the increment and the rates from the voltage and the resistance.